What a day. I mean, this has been fantastic. I've been kind of hanging out in the back, listening to everybody. So I just wanted to kind of say thanks for hanging out with us today. Angel Beat, Ron, and UiPath, and CodeFresh, and everyone that's been helping us out. And last but not least, all the customers out there. Honestly, we're just thankful that we get to present to you today. So thank you. So I'm just going to kind of go over a lot of actually kind of big topics, right? I'm going to be talking primarily about containers and serverless, and I'm going to ever so slightly touch on management and governance, spend a little bit of time with observability, and then last but not least, I'll go ahead and just kind of finish out with mobile. And so one thing I just kind of wanted to mention, and it's kind of the pattern that I kind of been hearing is, you're right. This is a crazy, awesome platform, and I spend a lot of times. And sorry for not really kind of introducing myself. Again, my name is Bryan Landes. I've been a part of AWS for about 2 years and 10 months, 11 months, something like that. And I spend a lot of my times with developers and all the way up to extremely large enterprises. And in fact, that's kind of where I spend the majority of my time. But the real reason why I'm kind of showing you this slide is that there's just so many different things that you could do with our platform. And as you can kind of tell, if you've kind of hung out until the very end of this day, there's a lot of event announcements. So feel free to keep searching, and I'll definitely send out slides and updates after this. But yeah, I just wanted to kind of talk about that ever so slightly. But nevertheless, the reason why I'm here today is talk about containers. I don't normally do a small little recap of how containers work. I'm just going to spend about 3 seconds on this, but just so you know, if you just kind of hanging on and you join this AWS talk and you're just kind of curious what we're talking about, just know this is kind of how you set up what is called a container, or it's a type of virtualization. It's a lightweight virtualization that you do with your compute. And what you can do is actually store your code, and then more importantly is these really troublesome dependencies. And then last but not least would be your runtime. So that might be Python, Java, JavaScript. And then what you could do with all these artifacts is actually store them into what is called an image. From there, you would actually take that image and you would actually store it into something called a registry. And this is just a place where you can actually store all these images, or basically your containers, into one central location for your artifacts. And then from there, just know that your instances or your EC2 instances would actually just pull that container and just go ahead and start running this. So, and this is what's really kind of revolutionized the world a little bit. So just kind of wanted to lightly touch on that. And when we're dealing with containers, you kind of see what you kind of see right here, right? You would have different EC2 instances, and then you would be able to run these containers onto these instances. And these could be many different types of microservices, right? This could be a front end for Amazon.com. This could be, it could be anything, right? Microservices are kind of up to you as a user to define. But what gets crazy though is when you start scaling up containers, it gets a little wild, right? There's 100,000 different types of microservices. You're managing networking and security. And that's why you kind of see this pattern kind of occur, which is what is called a container orchestration, or a container orchestration engine that actually will launch those containers onto instances or VMs, right? In our instance that I'll be talking about with AWS, that would be EKS, which stands for Elastic Kubernetes Service. And then last but not least would be ECS, which is Elastic Container Service. So just wanted to lightly touch on that, but this is kind of how the container world kind of works on AWS and in general, by the way, and in general. So with that being said, I just wanted to say just a small shout out to the container team and actually all the service teams. We all work really hard to make sure that we really meet our customers and the needs that they need. And so I just kind of want to give a shout out to all of them and all the other rest of the service teams. When we deal with our container landscape, we actually kind of look at it like this. This is actually how we look at our container landscape. On the very top layer would actually be part of, and I talk about the landscape, by the way, just because I will be kind of tossing some of these terms ever so slightly around, and I just didn't want anyone to kind of feel like they weren't part of the conversation. But up here at the very top, this would actually be part of our service discovery, which is called Cloud Map. This is really good if you ever are trying to figure out where your microservices may be and if you need to put any type of service discovery with those microservices. Over here on the right would be a service mesh. Sorry for my puppy barking in the background. Anyway, this is a service mesh, and what this would be is a managed service mesh. If you've never heard about this, this is basically an additional layer on top of container systems, and it's really good if you wanted to shift traffic to different types of microservices. Here we got Elastic Container Service and an Elastic Kubernetes Service. We are definitely going to be talking about that in a second, but basically this is our container management and orchestrations. The next layer would be Elastic Container Service or Elastic Kubernetes Compute Cloud. Basically, these are our VMs in the cloud that you're able to on demand and actually spin them on the fly. Fargate is actually our serverless compute engine. Why is this important? Because basically, this is the ability to actually launch containers without having to actually spinning up any kind of instances underneath it. So we'll actually manage that infrastructure for you while you just basically run your containers. And then last but not least is this registry where I talked about ever so slightly a couple slides ago, where you store your images. So these are all major components of containers. So just wanted to lightly touch on them because again, I'll be kind of talking about them. So the biggest thing that kind of actually was a launch for reInvent when it came to our registry was actually us making our ECR or Elastic Container Registry public. And so what that means is now you can actually store your images on our public registry. So if you're actually hitting that Docker Hub rate limit, you can actually now kind of start shifting your containers over here if you needed to. And also this is just a fully managed public registry, right? So it's highly scalable. It's actually backed by S3. And this actually also has native image vulnerability scanning involved in it. So if you actually start pushing your images to ECR, you can actually get some of those images actually scanned for free using Claire from the open source world. So nevertheless, this was really exciting announcement for us. We went ahead and made Elastic Container Registry public. But you know, I kind of talk on this ever so slightly because I get asked a couple of times, you know, why are customers adopting containers in general? There's a lot of major reasons, and we've kind of touched on them throughout the day, but the biggest part of this is actually, you know, velocity. And I would say that's probably the most important thing on this screen, the ability to actually bring your containers over to different environments, especially if you're an enterprise. And also the actual, you know, reducing the risk and able to actually have your containers go through all your CI/CD pipelines. And what's even better about containers in the end is, you know, we talked about portability and all this good stuff but you can be agile, right? That means you can literally spin containers up on the fly and do maybe something like A/B testing, where you would test certain part of your customers if they might like your website better, or if they might like another version, right? This is some of the really nice agile ways that you can utilize containers. And so at AWS, we have billions of EKS compute hours. We have hundreds of thousands of ECS customers. And you know, when we work with all of our customers, we continuously try to keep receiving that feedback. You know, we do launch a lot of containers, but in the end, I don't think we're done. I think we have a lot more that we can be doing. And the biggest trend, though, is kind of what we're seeing in front of you, this random clip art that I'm kind of showing you. These are some of the workloads that we are seeing at AWS. So this could be just typically launching applications, maybe some kind of backend, maybe a Ruby on Rails application. The second pattern is actually one of my favorite patterns to kind of follow. That's actually what we call the shared service platform. Basically, this is a central IT team inside of enterprises that help give out infrastructure to basically their coworkers, right? And how do you kind of govern that? And how do you share AWS services, with different AWS accounts? And basically, this is what those types of platforms kind of help govern. Enterprise app migration, I feel like, this might be kind of beating a dead horse, but basically this is how we would be able to move these applications that might be on-prem over to AWS. And then last but not least is machine learning. We were kind of shocked when we saw how much machine learning was kind of popping up when we first launched EKS. And nevertheless, just kind of like the last presentation from AWS, there's a lot going on with machine learning. And so that kind of leads me to a kind of multiple different ways of kind of looking at our container landscape. And one of those things that kind of looks a little bit different now is we've actually worked with Red Hat to be able to bring Red Hat OpenShift onto AWS. This was announced at reInvent, and basically this is a way that you could actually bring OpenShift onto AWS and be managed by on AWS. And so basically it's kind of building the two together with Red Hat and AWS. And basically you can make your OpenShift clusters with AWS console or the CLI. And again, we're tightly kind of integrated. Now, to kind of take a little bit more of a defined approach to where I'm kind of coming in from our announcements, I'm going to be breaking it down between these three, basically, focusing primarily on ECS and EKS, but just kind of setting the tone a little bit. But nevertheless, to kind of kick us off, I believe we're starting with ECS. So Elastic Container Service, we have been building with this for a very long time. In fact, when containers really were getting popular, we decided to make Elastic Container Service, which is our managed container orchestration and offering. And a lot of customers really enjoy ECS and the things that it delivers, right? But a lot of this might be the simplicity that ECS delivers, or being able to natively integrate with AWS more. Nevertheless, we've been working a lot with ECS throughout the years, and we're kind of seeing a common pattern, which is customers wanted to be able to use ECS, well, anywhere, right? And so what we did is we worked with our teams and actually have announced Amazon ECS Anywhere. And so basically what this is you can run ECS anywhere. It's like running ECS in your data center. You actually would have the same APIs, the same cluster management, and the same workload scheduling that you normally would have when you're actually deploying containers on AWS. You would have that same type of capability on-prem. The really nice part about this as well is that there's no need to update or maintain your orchestrator, right? This is actually all going to be running in our regions, and basically we would use an SSM agent to be able to interact with your ECS clusters on-prem. There's a great and fantastic videos that you can go check out. By the way, if you look at the bottom of my slides, you might see this part that says learn more. If you go to our reInvent website, basically that's all of our videos are on demand, and you can kind of watch exactly what I'm talking about, just so you all know. But nevertheless, yeah, this is one of our great announcements, basically to deploy ECS anywhere you want to go. And just so you know, some key benefits about this architecture, just kind of playing off of this. Again, your ECS control plane will be inside of a region. It's fully managed. Only information for managing tasks is sent to the control plane. We don't take any of the data off-prem. And then also just know that ECS is agnostic to any type of infrastructure. So this could be Raspberry Pis, this could be bare metal. It kind of depends on where you would like to have your ECS anywhere deployed. So I'm going to go ahead and hop over to EKS. If you did not know this, EKS is our Elastic Kubernetes service. This is an extremely popular service, and we have been working a lot on this. And if you didn't know, EKS it's a fully upstream type of experience with Kubernetes. We're not adding any type of proprietary software into the stack. It's certified conformant of Kubernetes, and basically EKS is a direct upstream. And at any time, we will always be supporting at least 4 versions of Kubernetes, and making sure to give you those type of varieties from those 4 versions. If you did not know, Kubernetes has a very fast release cycle. And basically, you get a brand new version of Kubernetes every 3 months with new features and updates and fixes from the community. So just kind of give you some context. Also, know that EKS supports control plane upgrades, and it also utilizes EC2 and also Fargate as well. But nevertheless, I think we kind of get it. But Kubernetes is an awesome type of software, and manage EKS is even better. So same kind of type of situation that we had with ECS, right? We kept on getting these requests where we would be having so many Kubernetes clusters or EKS clusters running that they wanted to be able to kind of do the same on-prem. And so that's what we also achieved. Starting at reInvent, we announced that we are now supporting EKS Distro and EKS Anywhere. I'm going to go ahead and break them down, but very high level as I'm kind of talking through this. EKS Distro is a literal distribution of EKS. Right, so this is an open source distribution that you can actually install into your vanilla Kubernetes clusters. And so basically, if you're running something like COPS or Kubernetes operations, or basically anything that might not be or might be self-managed or anything like that, you can actually install EKS Distro into that cluster. You may think to yourself, what am I getting by doing this? Well, for one, you get the same testing and security patching that we do at AWS. So basically all the security and all the backport fixes that we might be finding in Kubernetes, you would have that same type of experience. And also another big thing is that if you are an enterprise and you were launching these types of clusters, and you might have some on-prem clusters as well, your IT teams spend a lot of time trying to make sure that their Kubernetes clusters are basically compliant with one another, that they are able to spin up the infrastructure anywhere that they are. And so EKS Distro kind of helps you with that experience. If you have EKS deployed on your on-prem or your vanilla clusters, you're able to know that if you were to move those on-prem clusters over to EKS, that it would work just fine because you're using EKS Distro. But nevertheless, it's free and it is open source. And so this is some of the backfill or what is actually deployed into EKS Distro. I'm not going to spend too much time on this because it definitely will get much more technical. And I don't think anyone wants to hear me nerd down too much, but nevertheless, again, the biggest point is the security patching and tooling and those configs that we go through and test to make sure that EKS Distro is up to our compliance. And also we do push back those backport fixes as well. Now, just in the same vein of that, we also, heard from customers, well, thank you for the distro, but we also need to be able to deploy EKS Anywhere. And so we did. We actually announced this at reInvent, and the same kind of premise from ECS is ever so slightly different. But EKS is deployed anywhere. You can deploy it in your data center. You can be deploying this on any type of infrastructure. So bare metal, it doesn't matter, right? And what's nice about this, kind of when I was talking about the EKS distro, this is a really good way of having an EKS experience through your on-prem, your in-cloud, or wherever you may be, right? And so basically, we will give you the tooling to be able to spin up EKS in all these different parts, wherever you may want this to land in combination of using EKS distro. And so it would kind of look like what you see here. EKS Distro Anywhere, is again, it's a tooling to help you deploy your Kubernetes clusters depending on open source standards. Basically, this is another way to help you run EKS Anywhere depending on where you need to run it. What is interesting is that you would still have to run your own control plane. If you were running this with your own infrastructure, you would be given a Git runtime controller that would be able to sync your control planes, and that would be Flex. But a lot of this could be definitely kind of read through on our website, especially in the FAQ section of EKS Anywhere. Now, one major component that I kind of wanted to also mention with this is that with EKS being with EKS Anywhere and EKS Distro, we also wanted to basically really simplify all the day two operations. And day two operations normally have to do with updating clusters or being able to govern them after you originally launched your initial EKS clusters. And so we came out with something called EKS Add-ons, and this is the ability for us to manage your add-ons that are running inside of your cluster. Basically, you could say, hey, AWS, I would like you to go ahead and launch me, I don't know, maybe a VPC CNI, which stands for Container Network Interface. Basically, this is how you get networking in your cluster. You would just click a button and we would actually go launch that for you, and we would just manage that add-on. That takes away and abstracts away some of those day two operations again from your team. But nevertheless, it's really important, takes away the complexity of Kubernetes that it might bring. And then also the dashboard. We are adding more and more capabilities to our dashboard because we want to have a nice unified experience for all your EKS clusters. And so basically what this will look like, and it's already been deployed, but again, we're adding more features to this. You'll basically have one single pane of glass. So if you had your EKS clusters in, Tokyo, and you had your clusters in Canada, and you had your clusters in America, you would be able to see this all together. So definitely a lot of good things coming this way. Another thing that I find really, really interesting is the ability to also spin up Apache Spark jobs on EKS by using EMR. And so what the ability is, and what we have done, is basically you'll see these data science teams inside of these large enterprises or startups, and basically what they're doing is normally doing some types of ETL jobs, or maybe they're building out a data science platform of some sort, and they want to be able to use EMR, but they also have maybe something that they're using with EKS in the same way. Nevertheless, what this is that basically you can go ahead and launch your Spark jobs on EKS and still get all the nice functionality that you normally would be getting from EMR. If you did not know, EMR stands for Elastic MapReduce, and is actually configured to run Spark, I think it's like 1.7 times faster. So basically, if you read it on EMR, it's faster. And so this helps take away all the infrastructure and abstracts this all away from you. So nevertheless, this is definitely a big, big, big win, and congrats on the team for getting this done. One thing I also wanted to talk about before kind of moving on to different parts and other things is I also wanted to mention AWS batch jobs for Fargate. If you did not know, we also have a AWS batch service that's meant specifically for batch computing jobs. But what was a major win this reInvent was the ability to also utilize Fargate. Again, Fargate is our serverless compute engine. Basically, you ask AWS to run the container, and that's all you have to do. You don't have to manage EC2 instances underneath, and then you can also take advantage of Fargate Spot, which is up to about 70% of savings. If you're not really sure what Spot is, basically this is extra capacity that we have inside of our regions that no one's utilizing at the time. So serverless. Serverless is such a fun topic. I spend a lot of time with containers, but serverless and Lambda is one of my favorite topics, just because of the adoption and all the amazing things that you can do with Lambda. If you have never heard of Lambda, basically this is our serverless compute. So the idea is pretty simple. Basically, what we will do is that you could give us a function of your code, and we'll go run this code for you. So instead of just maybe bringing your containers, you could just bring your code, and we would just launch that on our platform for you. And so Lambda is what this is called, and basically Lambda is just growing and growing and growing, and is happening nonstop. So basically, again, AWS is just launching it or running your code in a very quick way. Obviously, definitely too, Lambda is definitely used all over AWS. So if you're kind of curious what this is, definitely check this out on aws.amazon.com. But yeah, Lambda is super powerful. Now, what we kept hearing from our customers was, okay, we got ECS, we got EKS, it's, kind of complicated orchestration engines. I'd rather just kind of use Lambda. Would there ever be a way to possibly combine both? And that's what we did. So that was the idea, is we wanted to be able to give customers the ability to bring over their container images over to Lambda and be able to utilize them. And so that's exactly what happened. We came out with Lambda container support at reInvent this year. And so what this is, and if you are an active user of Lambda already, so I'll try to kind of, tell you about the updates. But what this is basically, if you already have your container image or you're used to using containers, you can now bring that container over to the Lambda, and then Lambda will be able to go ahead and invoke that container for you. And the big thing is too with this is that if you're kind of used to the old or the zip memory limits, if you bring your Docker image, you can go up to 10 GB now. And so what that also kind of helps, unlock things for you is now you can do AI and ML workloads. You can possibly do gaming workloads, right? But we kind of just taken away those barriers from the size of your Lambda functions, and now you can bring your Docker images and invoke off them. And also another really big reason why you would do this is a lot of customers or enterprises are already kind of set on their CI/CD pipeline tooling. And so if you're already using your tooling for your containers, this might be another good way just to, laterally bring over your container to Lambda and invoke off of that. So I'll definitely break down some more instances about this, but I think we all kind of get it by now. And so, yeah, I guess I'll slightly touch on it a little bit more. Just kind of like how I showed off a little bit at the very beginning, this is how you would create the function within inside your container. Just like I said before, you would create some type of container, you would push it into some kind of registry. We're using ECR right here. And then what you would do is you would actually create a function with Lambda. It would pull the image from ECR, go ahead and optimize it, and then it'll actually deploy it, and then you'll be ready to invoke. So just kind of want to walk through that process. One of my personal opinion, I'm just kind of excited to talk about it, is we always are trying our absolute best to lower our prices. And we did that in a big way by lowering our prices of Lambda to 1 millisecond billing. And so basically, anytime your applications, or excuse me, when your Lambda functions are firing, you're only billed for the milliseconds in which that compute is ran. Just like everything on AWS, you pay for what you use. And so if your Lambda function is firing off much quicker, you save a ton of money. And it was really cool when we turned this on at reInvent, because basically you could see everyone's bill just drop by so much because we had to originally lock it down from the duration from 100 milliseconds. But again, that's taken away. Now, why is this a big deal? From the two things I just kind of told you about image size support and also the 1 millisecond billing, is now we have also made it easier to launch functions or larger functions. And so now we've taken it where you can actually have 10 GB of memory alongside 6 virtual CPUs for each execution in your environment. So now you have even more CPU and now even more memory. And so what you can do is, if you're already kind of figuring out how to use Lambda, you should definitely consider turning up that 6 virtual CPU, because you want your functions to fire off as fast as possible. If you do that, then you can actually take advantage of that 1 millisecond billing. Normally, people would actually kind of turn down those CPUs because you're trying to take advantage of, maybe being less than 100 milliseconds on the original billing cycle. So nevertheless, though, definitely be sure to look at the billing, change your function sizes, and utilize this type of infrastructure. One last thing is, before I believe we move on, is there was a lot of Lambda features and upgrades to our streams. So basically, if you were trying to figure out ways how to build analytic workloads, I recommend looking at the updates for Kinesis and DynamoDB streams with Lambda functions. Basically, you can invoke Lambda functions off of streams and DynamoDB streams to basically make analytic workloads on the fly. Right. Normally that would be a much larger process, but definitely this is some of the newer updates that you can get with serverless and Lambda in general. Management. So this is actually one of my favorite topics, and the idea is fairly simple, but you definitely have to kind of be in this problem to really know how hard it is. But out of everything I've been kind of talking about, you may have kind of gotten the slight hint that, microservices get a little bit wild, right? There's just a lot of moving parts. There's a lot of major things that are going on. And what happens is it gets really hard to build applications just because you're trying to move things around. You're trying to make this a very agile and automated process. And it's not easy for the sysadmins, right? It's not easy for the DevOps engineers, but it's not always easy for the developers as well. And so we really wanted to focus on that problem and really try to take that away. And so we came out with what is basically a new service to help take that away. And so the idea is kind of simple. So to kind of give a little backstory before I introduce it, excuse me. But basically, these are internal platform teams that are trying to build out platforms for their customers or their internal customers to be able to use infrastructure. So what they'll do is they usually set up as a PaaS of some sort. But nevertheless, right, again, it gets very difficult to manage hundreds of thousands of different types of deployments or microservices. And so you kind of get put into this type of situation where, as a DevOps engineer, you would have to kind of decide, do I want my entire enterprise or my entire team have specifically a platform as a service? Should I have, or only should I have an infrastructure as a service, or IaaS? Basically, this is what you would be giving your developers, right? Should I give them a lot of flexibility to let them spin up everything in the world that they want to? Probably not, right? But do I want to lock them down so much that they can't get anything done? No, you don't want either of those, right? And so what you're trying to look for is this ideal situation. And that's why we came out with AWS Proton. So AWS Proton is our fully managed deployment service for containers and serverless components and applications. And so what this is kind of, just to simply say it, it's like a bridge, right? It's like a bridge between your sysadmins and your developers. And what this does is it ties everything together in a seamless, consistent workflow. Your developers would be given a self-service catalog. So if they wanted to spin up Fargate, they would say, okay, I'm going to go ahead and click here, fill us a couple parameters, and then that would actually be able to spin up Fargate, right? ECS with Fargate. On the other side, the operators or DevOps engineers or sysadmins, they would actually be able to see all these things deployed for one, and they would also be able to standardize on these types of deployments. Again, if you're servicing over 40 different teams and deploying all their applications, it gets a little wild. And so what you try to do is figure out, how do I share these services with one another in a nice defined way? So nevertheless, again, AWS Proton is what we came out with to help solve this complex problem. But yeah, so definitely check it out. Observability. So if you notice, observability is an extremely important and hot topic. And the reason why is because observability helps you detect and investigate, but more importantly, remediate, right? And if you did not know, observability actually kind of focuses on 3 different aspects, and that is metrics, logging, and tracing. Metrics, I got to see what's actually running inside of my applications, logs. I actually need to see what they're doing, right? What actions and transactions have happened, tracing. How do I debug my microservices? How do I know from point A to point B that there might be something wrong or something along the lines of that might be slowing down or bottlenecking my application? These focuses are really, really important in the microservice world. And so we really wanted to focus more on this during reInvent. So we decided to kind of come out with something called AWS Distro for OpenTelemetry. And what this is basically an open source type of distro that is meant specifically for OpenTelemetry. This is a CNCF project, or a cloud computing native foundation project that's built specifically to help your applications have monitoring. So what we did is we made our own version just to be able to integrate into AWS a little bit better. So this is going to kind of be able to support what you see on the right-hand side. So CloudWatch, X-Ray, Elasticsearch, and other partner solutions. But nevertheless, this is just an open distribution for AWS OpenTelemetry. With that being said, though, we really wanted to make sure that we gave our customers more additional options. So we actually started thinking to ourselves, what were some of the cool things that a lot of customers are using? And that would be, one of them would be Prometheus. So Prometheus, if you did not know, is a open source systems monitoring and alerting toolkit. It's very popular, and it's really, really good with containers as well. And so you'll see a lot of enterprises using Prometheus as basically this tool to help monitor all their complex languages. And there's also great support for PromQL as well, which is a type of querying languages. Now, what we did is actually worked together, and we actually have announced that we are now coming out with Amazon Managed Service for Prometheus. Basically, this is one of our managed services specifically for Prometheus. We run this infrastructure for you, and we make sure that it's easily scaled, secure, and then last but not least, it just makes it really easy to get started with EKS and ECS and anything else that has to do with kind of microservices on AWS. Now, I cannot just mention Prometheus without mentioning Grafana. So Grafana, if you've never heard of Grafana, this is basically an open source tooling meant specifically for dashboarding. And these dashboards are really important because I can take all this data that's coming from Prometheus and basically visualize everything that I'm seeing. So those logging, those monitoring, those tracing. And so we worked with Grafana Labs to come out with Amazon Managed Service for Grafana. And so what this is a fully managed service that works directly, and sorry for my text being kind of pushed together there ever so slightly, but this is actually a managed service to run Grafana at scale. And so it actually supports everything that's coming through Prometheus. It supports many ISVs such as Datadog or Splunk. And then also we have tons of different data sources that you can funnel into this as well. So, CloudWatch, X-Ray, Elasticsearch, basically all the things that you can use to utilize with your environment. And yeah, what's also one thing I wanted to touch on this is also SSO integrated. So think about everyone in your company basically getting their own dashboard. Right? So everyone would get their own dashboard. You can tie that to your Active Directory and just kind of expand from there. So basically, not only are you giving observability to maybe an application, you're kind of giving observability to your entire enterprise, right? Which is a really hard thing to kind of solve. So I'm going to switch to DevOps and developer tools. So I think one of my colleagues ever so slightly kind of touched on this a little bit, but I'm just going to highlight some of these major things when it comes from DevOps. The first thing would be Amazon Code Guru. The biggest thing about this is machine learning meant specifically for your code. What it does is it will actually look at your code and basically give you flame graphs and analyze your code of where you might be able to tweak it to make it run faster. This might be really, really nice to use, say, for example, with your Lambda functions. You might be able to know how to install your libraries faster to be able to lower your bill. This kind of high level kind of things, right? The next thing that would be, or so the biggest thing that came out with this though was Python support. So normally we were just supporting Java. Now we are in fact supporting Python. And then also there is the security detectors. So if you're kind of curious of where you can put your DevSec ops or developer security operations, you might be able to use our security detectors to see if you might have any vulnerabilities in your code, and it also gives you suggestions if it does happen to find something. The next big thing is, again, I believe my colleague did touch about this, but it's DevOps Guru. This is the ML-powered cloud operations. It's meant specifically to literally look at all your developers and operators and be able to detect all the issues from those logs and monitoring and tracing, right? Basically, what this is finding inside of your entire environment is how to, one, quickly resolve issues that come up, right, or insights. And then number two is detect those things automatically. A lot of times customers will spend a lot of times really defining their environment to what alerts mean what, right? If you have a lot of things coming at you nonstop, alerting you nonstop, you won't know what is important when things are breaking, right? So this is one of the many things that we have at AWS that can help you with your DevOps. To make a little shift a little bit to chaos engineering, we came out with something for chaos engineering. Now, if you've never heard of chaos engineering, basically this is the premise that what I can do as a developer or a cloud user is I can inject failure into my applications to see if they're resilient. Right? So the idea is very simple. Basically, what I would do is I would actually ask certain parts of my applications to go ahead and break. And what I would do is actually architect around those failures. So my applications, if they were to break, I would already be basically aligned and ready to scale up or scale down depending on how they are breaking. And so the real problem with trying to test chaos engineering is, basically it might be a safety net, right? I can't just run this, randomly run applications on my production environment, but I still want to have chaos engineering involved. And so we came out with something called Fault Injection Simulator. And so what this is a fully managed service specifically meant for chaos engineering. And so what you can do is actually write up templates. You can say something along the lines of, I would like my EC2 instance to randomly blow up. And this could be a test where you could see if your auto scaling, would actually bring up another EC2 instance. Or maybe you wanted to, do something to RDS, which is your relational database service for AWS. Same kind of premise, right? And what's nice too is as an enterprise, you can share some of these templates with your teams and also kind of, test them randomly, depending on how you want to do this. But nevertheless, this is a really cool service. Another really cool service. Yes.
Bryan, we're running a little bit short on time. We've got one more session. So if you could try to summarize some of the highlights, that would be great. And so we can keep things flowing.
Absolutely. The only other two things I was going to say is Amazon Elasticsearch location service. This is really good for specifically if you're trying to add maps to your applications for geofencing and anything like that. I'll definitely give you all my deck. I think there was only about 3 more things, but I'll definitely give you my deck. Nevertheless, honestly, Angel B, thank you for having us today.